In this video, we're going to be naming acids and bases. We will start first with acids. Acids are composed in two ways. We can either have binary acids, and binary acids is when we have two elements. We will always have for an acid the hydrogen with a +1 charge, and in the case of a binary acid, we will have another element. And this other element would have a negative charge, of course. Another type of acids that we can see is those composed with polyatomic ions, and these acids are named oxoacids because the polyatomic ion usually has an oxygen. So the polyatomic ions have a negative charge, will have a negative charge, because the hydrogen will have the positive charge. So let's start with binary acids. So binary acids, as I said before, is just a hydrogen with its plus charge plus an anion, which is the element which has a negative charge. So for example, we would have hydrogen plus chlorine. And remember how we form our molecules. So this comes here. We cross the charges. We have HCl. And this HCl will be named hydrochloric acid. So let's see which is which. So in this hydrochloric acid, the acid part is the hydrogen, of course, and the hydrochloric means that it is a binary acid. And you'll see why when we name the oxo salts. So it's the hydro, it's the chloro, because it's the element that we have here. It's the element that we have here, and the ic part. So let's do another one. So if I change hydrogen, if I use hydrogen, of course, because we have acids, and we have S2 minus. So what acid will I have? Remember to cross the charges. So I have H2S. And remember, it's the hydro. It's the sulfuric acid. Right? So hydro, because it's 2. The sulfur, because it's the element, the termination ic. And acid, because we have a hydrogen. Let's do another one. We have hydrogen. We have, let's do a 3 plus and 3 minus. We change the charges, and I have H3N. So in this case, I would have a hydronitric acid. Again, the acid part, because of the H, the hydro, because it's binary, and the nitric, because it's a nitrogen. Okay, so let's see for the oxoacids. Oxoacids, it's a hydrogen again, because it's an acid, and it is a polyatomic ion. And here's a table of common polyatomic ions, and we'll use it to form our compounds. So let's start with the first one. We have a hydrogen, and we have NO2 minus 1. This is a +1. So the formula would just be HNO2, because remember, we crossed the charges. So what is the name of this? In this case, we're going to use the nitrite, it's this one. And this part, it's going to change to O's. So in this case, it's going to be nitrose acid. What happens if I choose the nitrate? So I have H plus NO3 minus, I form HNO3. This is the nitrate. So the 8 changes to ic. So what is the name of this compound? This is nitric acid. So it depends on the termination of your ion, if you name it O's or if you name it ic. What happens with this that have the hypochlorite, for example, or perchlorate? What happens with those terminations? So let's do hypochlorite. We have H plus ClO. This ion, it's -1, so I do HClO. Okay, so this ion, it's named hypochlorite. So I keep everything, and the I changes to O's. So in this case, it's going to be hypochlorous acid. So I keep the name of the ion and I change it according to the rule that I said first. Now let's do with a perchlorate. Perchlorate has 4 oxygens, still has a -1 charge. So I have HClO4. This is perchlorate. And I keep everything. This 8 changes to ic. So I have perchloric acid. So just to remember the rule before we go to bases. So let me go back. So let's remember the rule. If the polyion ends, polyanion because it's negative. If the polyanion ends in ite, you change it to O's acid. If it ends with 8, you change it to ic acid. And that's the rule. We actually keep the prefixes. Whenever the ion has a prefix, we keep it. Okay, now for the bases. In the case of the bases, the basic part of my molecule, it's going to be the hydroxide ion. The hydroxide ion is OH -1, and we're going to combine it with a metal. And here I have the monoatomic cations, right? So let's just do some exercises for this. I have sodium, which is a +1, plus the OH minus my formula. I cross them, so I have NaOH, and this is going to be sodium hydroxide. So just like we did before, we do not change the name of the metal. We just add the name of the negative part. So for example, I have silver plus OH minus. So I have silver, I have silver hydroxide, and the formula, it's going to be AgOH. Remember, the charges go one and then the other one. Let's do one where the charge is variable. One of the variable charges that we have is for gold. Gold can either work with a 1 or a 3. So if I have gold 3 plus OH minus, I cross my charges, so I have AuOH3. So because gold works with a variable charge, the name of it needs to identify that. So I have gold 3 hydroxide. What about iron? Iron also works with a variable charge. So I have iron 2. I'll work with 2. Iron works with 2 and 3 plus the OH part. So I'm going to have FeOH2. So the name for this would be iron 2 hydroxide. So remember, every time we work with metals, we need to ask ourselves, does this metal have a variable charge? And if it does, you need to specify what charge you're working with. And you specify with the Roman numerals. And that will be it for this ones.